chromatography. It is a method in which components of a mixture are separated based on their differential interactions. Now, if you are given a mixture of components, assume there are circles, squares, pentagons. Now, assume this is a mixture of components, 3-component system. Now, if you need to separate them out, what you can use this technique which is called the chromatography. And after the separation of each and every components, you can use them to either analyze, quantify, identify, or you can even purify the separated components. In upcoming videos, I'll be talking about different techniques or different types of chromatography. Now, in those types or in those techniques, you'll find each and every chromatographic technique contain 2 chemical or physical phases. What are those 2? First one is stationary phase, which is it can be of the porous bed, bulk liquid, layer, or otherwise it can be a film that is generally immobile. And the second one is mobile phase, which is a fluid. It can be either gas or liquid that percolates through or over the stationary phase. Now, in this picture, you can see a column which is containing a stationary phase, and you are having this sample. You need to separate them out. So the mobile phase is also getting added into this column together with the sample. The mobile phase travels through the system and carries a sample component with it once the sample has been applied or injected. The stationary phase, which is remaining here, is held within the system by a support and does not move. The stationary phase is immobile inside the column, which is held within the system by different types of supports. And we'll see how this happens. Now, you can see some components move quickly. How this is happen now? Again, we can see that. Yeah. So, as the sample components pass through the system, the components that have the strongest interaction. So, what are the components? Now, if you take this one, we'll feel the circles have strongest interaction with the stationary phase. They will move very slowly because they will be more highly retained by this phase, which is the stationary phase, and move through the system more slowly than the components that have weaker interactions with the stationary phase. Now, triangles are having weaker interactions with the stationary phase, so they don't like to stay in the stationary phase. And this leads to a difference in the rate of travel for these components and their separation as they move through the chromatographic system. Now you can see triangles move quickly, so then you can separate them out. Thereafter the circles come, then you can separate out circles, and there's a small time gap between these components because of the interactions between the stationary phase and the sample component. So accordingly you can separate them out. Again, we can see triangles move quickly because they are having weak interactions with the stationary phase. Then circles come because they are having some interaction. So they like to stay with stationary phase. Then we'll move on to the other one. Now assume this is the column that we have discussed in the previous case, and this is a mixture of girls and boys. You need to separate or differentiate them out. So assume this is a road or small path that they need to go for their destination. Assume this place is their destination, and there are some girls in this path, and what you are doing is, now of course you can physically distinguish who are the girls, who are the boys, but for the moment we will consider their behavioral characters. Now if you release them out, what will happen is boys move quickly to their destination than girls. Why is that? Now, you know, girls like to share their information. If they meet their friends, they like to chat for a moment, and they show a small late or small time gap rather than boys. So they take small time to come to their destination. So if you need to separate girls from boys from this mixture, first you can take boys out, then after that girls come, then you can separate them out. So that means there are girls, so girls they are similar types, so they are having some interactions because they are in similar, they have sharing similar characteristics. Okay, assume this is the stationary phase and this is the mobile phase. Then there will be some interaction, so they move slowly than boys because they are in different gender. And then we'll see what are the types of chromatographic techniques. There are different chromatographic techniques, as I mentioned in previous slides. It depends on the mobile phase and the stationary phase. Most of the time, as I mentioned, mobile phase is either a liquid or gas. It may be a fluid. All the time it is a fluid. And stationary phase may be either the liquid or sometimes a solid, thin layer of silica, paper. Likewise, the stationary phase may be somewhat different, but mobile phase almost all the time it is a fluid. And these techniques are having different terms. Now if you take mobile phase as liquid and stationary phase as liquid, that is called the partition chromatography. Likewise, there are different terms: gas chromatography, ion exchange chromatography, gel permeation, ion exclusive chromatography, thin layer chromatography, and paper chromatography. If you like to watch more related videos, please subscribe my channel and press the bell button to get notifications. Thank you.